I'm David Meviki, and I'm a biology professor at the University of Notre Dame studying terrestrial ecosystems and environmental change. Today on Wired, I've been challenged to argue whether or not the carbon pool will increase in size over the next 100 years to both an art history major and an expert ecologist.
I've heard a lot about climate change in the news, especially carbon in the atmosphere. That being said, how do you think the amount of carbon will change in the future?
Over the next 100 years, the terrestrial carbon pool will likely decrease in size. What I mean is that all the carbon held within the land, plants, trees, and soil will be reduced.
I understand where you're coming from, but unfortunately, it's been quite a while since I've taken biology. Why is it that you think this amount of carbon will decrease in the future?
Well, one potential cause of the reduction of carbon in the terrestrial ecosystems is deforestation. Forests are major carbon sinks, which basically means that they hold large amounts of carbon, whether that be through live trees, soil, or dead matter. When forests are cleared by deforestation, the amount of carbon stored here is released into the atmosphere, reducing the amount of carbon within these plants and soil. Take, for example, the Amazon rainforest. Currently, over 20 million hectares, almost the size of the UK, have been deforested, greatly decreasing the terrestrial carbon pool, which contributes to increased rates of carbon in the atmosphere and global temperatures too.
That's terrible. I'm just starting to get it now. I'm from Los Angeles, and there's been a lot of wildfires lately. Would these types of natural disasters also contribute to decreasing amounts of terrestrial carbon?
You're exactly right. Disturbances that stem from climate change and global warming can also decrease the future amount of land carbon. As the Earth warms, major natural disturbances like wildfires and droughts are becoming more frequent. One example of this is if a fire burns down a tree, much of the carbon that was stored within that tree burns and enters the atmosphere. When it enters the atmosphere, scientists would say that it has left the land carbon pool and entered the atmospheric carbon pool, effectively decreasing the amount of carbon stored in the land. On a larger scale, these wildfires can burn millions of acres of land, causing relatively large shifts in the carbon pools. Similar thought processes can be applied to other natural disturbances. Does this make sense to you?
Yes, that makes a lot of sense. So climate change is killing plants, leading to a decrease in land carbon pools.
Exactly. I'll leave you with one more factor that may contribute to a reduction in terrestrial carbon: permafrost thawing. This is frozen soil primarily found in areas like the Arctic that store large amounts of carbon underground. Microscopic organisms called microbes usually break down carbon and emit it into the atmosphere, decreasing the land carbon pool. Yet in regions with permafrost, the roots are locked in ice, protecting them from microbes. But as the planet warms, the roots become more accessible, increasing productivity, or the rate at which they can break down and emit carbon. This reduces the overall land carbon pool.
That's so interesting. Thank you for helping me understand the future of terrestrial carbon.
I've been doing research on the effects of climate change. Over the next 100 years, how do you think the carbon stocks in terrestrial vegetation and soils are projected to change?
The common consensus is that both vegetation and soil carbon pools are at risk of decline. There are three main mechanisms that significantly drive this progression. Let's start with deforestation. When forests are cleared, we lose not only the immediate carbon stored in trees, but also the continuous inputs of organic matter into the soils. This disrupts root networks, diminishes soil organic carbon reserves, and accelerates the release of CO2 into the atmosphere. Beyond that, forests function as critical carbon sinks as they absorb carbon through photosynthesis. When the removed stored carbon isn't just released, the system's capacity to keep pulling carbon back out of the atmosphere is also eliminated.
So, deforestation both destabilizes soil carbon and removes one of the planet's most effective buffers against atmospheric CO2.
Yes, the second mechanism is climate change disturbances. Anthropogenic warming is intensifying the frequency and severity of wildfires and droughts. Wildfires can vaporize decades of accumulated biomass carbon within days. Furthermore, droughts weaken plant growth and increase tree mortality.
When plants are stressed, they take in less carbon, correct?
Yes, that's right. With that, drought-stressed forests are much more vulnerable to fires, which aggravates the losses. When you add storms and hurricanes into the equation, there is great possibility for massive physical teardown. If trees collapse and biomass destroyed, the ecosystem resets and their ability to store carbon is delayed.
So, disturbances don't just release carbon in the short term, but its long term effects on the entire ecosystem can affect the overall ecosystem's ability to recover and sustain its ability at storing carbon.
Exactly. This leads us to the third mechanism, which is consequences of microbial productivity and permafrost thawing on soil carbon amounts. As it gets warmer, microbial productivity increases, allowing organic matter to be broken down at a faster rate, emitting more carbon dioxide into the atmosphere. This contributes to the positive feedback loop, wherein the warmer it gets, the more carbon escapes, accelerating the thawing and the amount of soil carbon lost. Arctic permafrost stores nearly 1,700 billion metric tons of frozen and thawing carbon. When it thaws, the carbon becomes more accessible to microbes, which releases it as both carbon dioxide and methane. All these mechanisms contribute to the potential decrease in the future terrestrial carbon pool.
Thanks for sharing all that. This will greatly help my research.